Here's your first video for pre-cal. This is section 1.1. It's basics of functions, and I'm going to try to go through some of these things kind of quickly because you've done them before, and these are the different topics within this section. We're going to start with interval notation, and this is something I'm not sure how much was stressed in Algebra 2, so I'm going to go over this one a little bit more thoroughly than some of the other things. What I have right here, this right here, is called set notation, and that's how you've been writing inequalities. If x is greater than or less than something, that's called set notation. What we're going to do is write this a different way, and it's called interval notation. This is how you graph it on the number line. If I ask you to graph an inequality, wow, that looks bad. Graph. If I ask you to graph an inequality, that's what it's going to look like, and you should know how to do that. You've done that before. Open circles if it's not equal to, closed circles if you are equal to something. So you have set notation. This is the graph of an inequality, and we're going to change this to something called interval notation. And the way this one would be converted to interval notation, notice I shaded everything between 2 and 5. So in interval notation, the way I write this is I started my shading at 2. Even though it's an open circle, I'm still going to start at 2. And then I'm going to shade all the way to 5. So it's 2, 5. And since I'm not equal to 2 or 5, we put parentheses around the end. Now I know that looks like an ordered pair that you would plot on the xy axis. It's not an ordered pair. This is interval notation. It's another way to write inequalities. So that's how you would write x's between 2 and 5, not including the ends. This one is a little bit different. I'm going from -4 to 0, and I have it graphed here. But this time I'm including the -4. It's filled in. So if I convert this one to interval notation, I'm starting at -4. I'm shading all the way to 0. That's where I stop. And then I want to include the -4. It's filled in. So instead of parentheses, we will use brackets. So I'm equal to -4, still not equal to 0. So I'm going to put a parentheses around 0. So there's the first two. Just remember, not equal to is parentheses, equal to is a bracket, and starting number shading to the ending number separated with a comma. Here, changing it just a little bit, this is x is greater than 12. For this one, we're going to start at 12, but we never end the shading. So when I convert this one to interval notation, I'm starting at 12. Going from left to right, I start at 12. It will be parentheses because I'm not equal to, comma, and we never stop. We shade forever to the right, so I will shade forever towards infinity. And you always put parentheses around infinity. It's impossible to equal infinity. So if you're doing interval notation with infinity, always parentheses. Never use a bracket. Another one down here. If x is, here I have x is less than or equal to pi. So I put pi on the number line. And notice on my number lines, you don't have to count from 0 to whatever. I'm going to assume you know how to count. So don't put a tick at every single number. Just put the ones that are important. So here I have pi. I'm equal to, so I shade it. I'm less than, so I went to the left. And this one to interval notation. This time I started way over here to the left, so I'm starting at -infinity. And I stopped at pi. Infinity, you never put a bracket around, so parentheses around infinity, -infinity. We are equal to pi, so I'll put a bracket around pi. And then there's one more I want to do. I didn't think about this one until just now, so I'm going to add a fifth one. And those are ones like, I could say x is less than 6, or x is greater than or equal to 12. And these are the ones that don't have the overlap. So if I were to graph this, my interesting numbers are 6 and 12, so I'm just going to put those two numbers. Less than, open circle, shade to the left. Greater than or equal, filled in circle, shade to the right. And if I look at this one, I have two shaded regions, so we're actually going to need two sets of parentheses to represent this. So in interval notation, you read from left to right, so I'm over here on the left, and I start at -infinity, and there will be parentheses because you never equal infinity. I stop at 6, close parentheses, and then we start over. I go at starting at 12. Keep going. There's no shading there until I get to 12. That is equal to, so I will bracket 12. And I never stop shading after that, so on to infinity, parentheses. And the way you separate that, you don't write the word and or put parentheses or a comma or anything like that. You put a little u, which technically represents union. But just know that when you're doing interval notation, you have multiple parentheses or brackets you join them with that little u. So there is your interval notation lesson. That took a little bit longer than I wanted, but that's kind of important. You're going to be expected to know interval notation pretty much from here to the end of your mathematical careers. So moving on, functions, and I'm going to breeze through this. You should have learned this in like 7th grade. It's a relation where each member of the domain is paired with only one member of the range. Usually it's x's and y's. If you're in science, that may change a little bit when we get into the actual applications. But let's look at a few relations here. Here we have a chart, and we have our x's and we have our y's. If you notice the x's, I have -8, -5, 0, 3, and 6. None of them are repeated. -8 goes to -5, and that's it. It doesn't go to anything else. -5 is going to -4, and nothing else. None of my x's are repeated. Although if you notice, I do have repeated y's. That doesn't matter. So number 1, each x value is only going to one y value. So number 1 here, that is a function. Number 2, if we look at this one, -6 goes to -7 and nothing else. 2 goes to 3 and nothing else. 5 goes to 8. But here's 5, it's going to 9. You can't have 5 paired with 2 different y values. So for this reason right here, this is not a function. 5 cannot be paired with 2 different y values. Not a function. And a brief lesson, that's shorthand for function, fxn. Here's same thing, except it's ordered pairs instead of in a chart. Notice none of my x's are repeating, so this one's going to end up being a function. Why didn't I abbreviate it? I just wasted like 3 seconds of my life. Even though my 7, the range is repeated a little bit, but that's okay. It's the domain we're worried about. So that's if it's an ordered pair. If you have graphs, y'all may remember the vertical line test. If you have a vertical line, and if you drag it across the graph, so let me draw a vertical line here. So here's a vertical line, and if I drag that vertical line across my graph, if I ever touch the graph in more than one spot, then it's not a function. And notice this one throughout the graph. I touch my graph here, and I touch it again here. This is not a function. If your vertical line touches the graph more than once, you're not looking at a function. Take the vertical line over here to number 5. As I pull it across, doesn't matter where I put my vertical line, I only touch the graph once. I never touch the graph twice, so this one is a function. So identifying functions, there you go, moving on. All right, evaluating functions. Again, you should have been doing this for like 6 years, so I'm not going to go over this very much. Here you have f of x, here you have f of values. You plug the values in for the x. So f of 2 is going to be, instead of x squared, it's going to be 2 squared plus 2 times, take out the x, plug in the 2, minus 1. Follow your order of operations. 2 squared is 4, plus 2 times 2 is 4, minus 1 is 8, minus 1 is 7. There's your answer. With negatives, just watch your parentheses. Plug in -3 for x. That is quantity -3 squared, plus 2 times -3, minus 1. Follow order of operations. -3 squared is 9. 2 times -3 is a -6, so minus 6 minus 1. 9 minus 6 minus 1 is 2. Getting a little bit more complex, if it's 4x, if I plug 4x in, it's parentheses 4x squared plus 2 times, and anywhere there's an x, I like parentheses. Just stick with parentheses. It helps you eliminate mistakes. Quantity 4x squared. 4 squared is 16. X squared is x squared. 2 times 4 is 8x minus 1. And notice with this one, you cannot combine anything. Those are all unlike terms, so as ugly as it is, that's your answer. Last one here, f of x plus 1. How long is this? 8 minutes. Not too bad. So f of x plus 1, if I plug x plus 1 in, hey, I changed to red. Check that out. So it's x plus 1, quantity squared, plus 2 times quantity x plus 1, minus 1. And you have to be careful, y'all. This is a very common mistake, even though you know better. X plus 1 squared. You have to write that side by side and FOIL the whole thing out. X plus 1 times x plus 1, plus 2 times x plus 1, minus 1. Now if you square all that out, x times x is x squared. X times 1 plus 1 times x ends up being 2x plus 1, plus distribute the 2, 2 times x, plus 2 times 1, minus 1. Then we combine our like terms. X squared is a loner. See, 2x plus 2x is 4x. 1 plus 2 minus 1 is 2. And there we are. All right, so evaluating functions, just plug in whatever in for the x's. Gets a little bit hairy when you get into piecewise functions. This is called piecewise because one function g of x is represented by both of those. And you just have to pay attention to where the number falls. -3. Well, here this is x is less than 2, x is greater than 2. -3 is smaller than 2. So for that first one, we're going to look up here. Then I'll plug in -3 for the x up there. 2 times -3 plus 1, because -3 does fall on that interval. See, 2 times -3 is what? -6 plus 1 is -5. There's your answer. If I were to plug in 5, well, now I've got to start over and think, where does 5 fall? 5 is bigger than 2, so I'm going to plug in 5 for that x. So that'd be 5 squared minus 3. 25 minus 3 is 22. Plug in the 2. Where would I plug in 2? 2 is not less than 2, but 2 is equal to 2. So again, I'm going to plug it into the bottom. 2 squared minus 3, and that ends up being 1. Again, piecewise functions. Am I going too fast? Whatever. You can pause it. All right. Let's see. -6, another piecewise function. -6 is less than 4, so I'm going to plug in -6 up here. That's an absolute value function. So the absolute value of 2 times -6 minus 3. That's the absolute value, -12. Minus 3 is -15. The absolute value of -15 is +15. There's your answer. Notice this is a 3-part piecewise function, which is fairly common. H of 4. 4 is not less than 4, but 4 is equal to 4. So this will actually go into the bottom one. And it says here that your function is just 7. There's nowhere to plug in the 4. So H of 4 is equal to 7. That's it. Nothing else to do. So evaluating functions, again, you should have been doing that for like 4 years. Kind of went through that a little bit quickly. Where are we? 11 minutes. Okay, one last thing, and that is finding domain. And this is going to roll back into interval notation. So finding domain. The way I like to think of domain, if you're given equations, is what really screws up this equation. So I'm looking at this equation, and what I see is a fraction. And one thing you have learned is that you can never divide by 0. It makes the world blow up, and the Math League of America gets angry, and gnomes will attack you. So I'll look at this, and I'll look at my bottom, and I know that in a fraction, my denominator can never equal 0. So what I'll do to figure out my domain is I'm just going to set my denominator equal to 0, and I'll solve that equation. And I determined that 7 actually makes my bottom 0, so my domain is actually x cannot be 7, but it can be anything else. Now this is an interesting one for interval notation. If x cannot be 7, but it could be anything else, then that means we have an open circle at 7, because I can't be 7, but I can be anything before, and I can be anything after. So if I were to put that in interval notation, my shading begins at -infinity, but I have to have a brief stop at 7. So I go up to 7, I'm not equal to, so I'll put parentheses, and then I start shading again at 7 onto +infinity, and we join that with little u. So for now, until we get really familiar with interval notation and we're real comfortable with it, I would accept any of those. X is not equal to 7, the number line, or interval notation. But I expect you to, at one point, get familiar enough to be able to do that. So fraction cannot, the bottom cannot be 0. Here I have another fraction, so I'm going to look at the x squared minus 25. And I'm going to set that equal to 0 and solve. What you're going to be tempted to do is move the 25 over. X squared equals 25. And then you're going to say x is equal to 5 because you're taking the square root, right? How many of y'all did that? Raise your hands. I see you. All right. The problem with that is you forgot the dreaded plus or minus. Anytime you take the square root, you have to remember plus or minus. So this one, you could solve it that way, but you'll probably forget the plus or minus. So I'm going to show you a safer way to do that, and you know this, you just weren't thinking about it. Anytime there's a squared something, I'm going to solve by factoring if possible. That's a difference of squares, x plus 5, x minus 5, and set each factor equal to 0. This one, -5 makes the first one 0, +5 makes the second one 0, but you cannot equal those because that's what made my denominator 0. Now again, the interval notation with this one's going to be tricky. X cannot be -5 or +5, so I'll put open circles there, but I can be anything else. I can be anything else. I can be anything else. And so when I do interval notation, I start walking along the number line. So here I am. If I move along the number line, I notice my shading begins at negative infinity. And then here I am waltzing along. Oh, my head fell off. Oh, and my arms. Hey, check that out. All right, so I have walking legs and torso. I get to negative 5, and I stop for just a second. I'm not equal to negative 5, so I put parentheses. You never equal infinity, so I put parentheses. But then I begin shading again right after negative 5. So as my legs and torso keep trucking along here, I notice I start shading again, so I start at negative 5, not equal to, open circle. And I shade all the way until I get to positive 5, not equal to, so I put parentheses. And here's my torso and legs. Let's see, so I stop shading for just a minute, then I pick up shading again at 5, and I will continue shading forever after 5. We never stop, all the way to infinity. So there is your answer for the domain to this problem. Notice I'm not paying attention to the numerator. There's absolutely nothing wrong with the top being 0. You can have 0 in the numerator, so don't let negative 8 be one of your answers. The only thing we care about is the denominator. And then we have one more. Yeah, this is taking longer than I wanted to. Oh, well. One more. And this is a square root. So this is a little bit different. I have to think, what really screws up a square root? Well, if you remember, you cannot take square roots of negative numbers. So if I had square root of negative 9, you can't do that in real world. Now, in the real numbers. Now, you do maybe remember that that's 3i, but 3i is imaginary. It's not a real number. You can't take the square root of a negative number. So what I have to remember is if I have a radical, whatever's under the square root has to be positive. And you can take the square root of 0. It's okay if this is 0. So to find the domain of a radical, I take what's under the square root, and I just think, all right, it has to be something bigger than 0, or it can equal 0. Anything else is off limits. And then I solve this equation. I'll move the 6 over, negative 6. I'll divide by 2, greater than or equal to, negative 6 divided by 2 is negative 3. And so I get x is greater than or equal to negative 3. If you want to put that on a number line, you could. Close circle, greater than is shade to the right. Interval notation, I started at negative 3. I ended at infinity. I do equal negative 3. You never equal infinity. So there's the domain for this one. And right now, domain, all we're going to worry about is fractions and square roots. We're going to add some other kooky things in the future. That's all we have for now. So that took a lot longer. This may be one of the longest videos of the year on the first night of school. Isn't that great? Anyway, if you have any questions, shoot me an email, post it in Edmodo, whatever, and we will talk about it in class tomorrow.